All right, so this is just my honors class, unless any of you regular folks are feeling really, really ambitious. So the rational expressions that we've talked about before, let's recap some of them before the semester's over. So number one is subtracting. Now remember, when it comes to adding and subtracting, you must have a common denominator first. So give me a second here. I'm going to open my questions up on another screen so that I can go to my sketchpad here. What is it? Okay. So let me pull this up and we'll just write on this. So our problem is 2a over 15b minus 9b over 5. Now I'm subtracting, so again, I need a common denominator. So what I can do, I'm looking at the 5 and the 15 right now. I know I can make 5 into 15 if I multiply by 3. But I also need a b in this denominator, so I need to make sure I can multiply a b to this as well. So that'll make 15b my denominator in the the right or second fraction. But let's see what else we have. Let's see what the numerator turns into. So I have 2a over 15b. There's nothing I need to fix about this fraction. But on top, on the other one, I'll have 9 times 3, which makes 27b to the second. And then on the bottom, I'll have 15b. So now I can subtract. So the common denominator stays 15b. But now I have 2a minus 27b to the second. And as far as I know, that's as much as that's going to simplify. So I guess we'll have to leave it at that. Number 2, now they're subtracting 1. So now they're 1, we need a common denominator 4. So again, your first and primary goal should be to make a common denominator. So this is interesting because you can't just plus 1 to this denominator to make it match. You can only match denominators by multiplying terms with it. So what I need to do is I need to multiply this denominator by an a plus 1 so that it has an a plus 1 like the other one has. And I need to multiply this denominator by an a so that it can have just a plain a like the other denominator has. So my common denominator will be a and a plus 1 be multiplied together. But I have to do those things to their numerators as well. So when I do that, this fraction, 1 times a plus 1 on top, that's just a plus 1 on top. And on the bottom, I have a plus 1. Minus, and the other one will be 2a to the second, and then, of course, a plus 1. So I've got my common denominator. My common denominator is going to stay my denominator, okay? And now I got to subtract the top together. So there are no like terms on the top, a plus 1 minus 2a squared. So really, it'll just be the minus 2a squared, a positive a, and a positive 1. And I guess that is it, because if I'm looking at my answer choices, it doesn't say to simplify it the most. If it said simplify, then I would have to check to see if there's another simplified version of it. But it says which of the following is equivalent. Now I already know that's equivalent. So that's got my answer in it. So here's my answer. Number 3. Number 3 is dividing. So let's talk about dividing. Dividing is pretty easy. So the first thing I'm going to do is keep, change, flip. So I'm going to keep my first expression exactly the same. I should really factor it first, but I'll factor, I guess, in the next step. Change division to multiplying, and then flip the other fraction. So x minus 4 on top, and then 2x plus 6 on the bottom. So I need to factor absolutely everything I can factor. So starting at the top left, I know I can divide these both by 6. So 6 can come out, and that'll factor into x squared. What's 54 divided by 6? 9. So x squared minus 9, which also continues factoring into x plus 3 and x minus 3, because that's a difference of squares. So that's the numerator on the top left there. The denominator for that, so this one I'm using product and sum for. So two numbers that multiply to 8 and add to negative 6 would be negative 4 and negative 2. So those factors would be x minus 4 and x minus 2. And I'm multiplying it with x minus 4. That's already factored, so that's convenient. There you go. And then the bottom here, I can divide both of these by 2, the GCF there. So that'll be, take a 2 out and make that x plus 3. So now it's just about canceling things. So let's look for everything I can cancel. I know this x plus 3 will cancel with this x plus 3. That x minus 4 will cancel with that x minus 4. And then the 6 divided by 2 will become a 3 over 1. So this at the end of the problem becomes 3. And then x minus 3 is still up on the top. And on the bottom, I will just have x minus 2 times 1. But x minus 2 times 1 is still x minus 2. So there's your answer, I guess. Number 4 is actually pretty easy. We have 6a to the 4th, b to the 3rd over 2a to the 5th, b to the 8th. So this is just about simplifying and canceling out. So 6 over 2 can reduce to 3 over 1. So as far as your answer goes, you'll have 3 on top, 1 on bottom. You have 5 a's on the bottom, 4 a's on top. So these 4 are going to cancel out, and you're going to have 1 a left on the bottom. And then 3 b's on top, 8 b's on bottom. So these 3 b's are going to cancel out, leaving you with 5 left on the bottom. So your answer should be a 3 on the top, and a, b to the 5th on the bottom. Number 5. Number 5 is a straight up cancel it out kind of thing. So I think, I guess they write the answer a little bit differently, but you can see that in number 5, the x minus 1s are going to cancel. So I'm just going to go ahead and write the stuff without the x minus 1s. Now this bottom part is a difference of squares that comes from x squared minus 9. So that's what's making sure you remember from your simplifying days. So it does multiply them back together and get you that as a result. So number 6, this is one where I would multiply everything together first and then simplify at the end. So that's exactly what I'm going to do. 3yz to the second, 8x to the second. So multiplying across, 2 times 3 is 6, x to the second, yz to the second. That just says everything on top. And on bottom, I have 5 times 8, which is 40. And then still an x to the second, still a y to the second, and then a z. So 6 over 40, that's going to reduce to 1. Wait. No. I guess I can divide them both by 2. So that'd be 3 over 20. I thought there's more I can do than that, but I can't. 3 over 20. These x's are going to straight up cancel. I'll have this y cancel with 1 from down there, so I'll have 1y at the bottom, and then this z will cancel with 1 z from up there, so it'll leave a z on top. So there will be your answer. Number 7. Number 7 is pretty nice because it's already got common denominators. You notice you're subtracting in this problem. So again, anytime you're adding or subtracting, you have to have a common denominator. And in this case, we already do have that common denominator. We're just going to subtract the top. So 3 minus x. There it is. You could write this as a negative x plus 3 as well. So I don't know what the answer is that you need to use, but one of those will work and you'll be good to go. Number 8, similar to a problem we did earlier. Let's write it out. We have x squared minus 6x plus 8 over x squared plus 3x plus 2. Keep, change, flip. So 4x plus 8 and x minus 4. So again, after I've done my keep, change, flip, it's all about factoring. So this top one, I'm going to factor by product and sum. So I'm looking for what two numbers multiply to 8, positive 8, and add to negative 6. And that would be negative 4 and negative 2. So that's going to factor, that numerator is going to factor into x minus 4 and x minus 2. The denominator for this, that factors using product and sum as well. So I'm looking for two numbers that multiply to 2 and add to 3, and that's going to be 2 and 1. So that's going to be x plus 2 and x plus 1. And now this top right fraction, that numerator can be divided by 4. So just factor GCF of 4 out, and you'll have x plus 2. And then the denominator is still x minus 4. That's already clean and factored. So canceling some stuff out. This x plus 2 will cancel with this x plus 2. This x minus 4 will cancel with that x minus 4. So all I have left would be a 4x minus 2 over an x plus 1. All right, number 9. I think number 9 you guys can handle. The x minus 1s are going to cancel. 2 over 4 reduces to 1/2. So if you do those things, I think you'll know your answer. The x squared is not going to go anywhere. So yeah, I'll let you guys do that one. Number 10, another subtraction problem, but again, you need a common denominator. So we have 2x over y squared minus 1 over y. So to have add a common denominator here, all you need to do is multiply the second equation by a y, and that'll make the denominators match. You'll have y squared as your common denominator. So this will be y over y squared. So I've got my common denominator. Now keep your common denominator. Remember, you don't have to do anything to worry about changing that. But now you have just on top 2x minus y. And I don't think there's any more you can do to cancel or simplify that. So number 11. Number 11 is, again, you can cancel some stuff out here. This is actually, it looks kind of weird, but it actually works pretty nice. I just think it looks weird because maybe that x plus 1 isn't in parentheses, but I always like to put parentheses on things. So it's obvious those x plus 1s are going to cancel because you are multiplying here, and you can cross cancel when you multiply. So really, I think those are going to go away. You're just going to have 4/3. Number 12, which I just realized I need to fix that. Number 12, I guess it doesn't really matter. All right. So let's rewrite this, okay? Because it's really like a division problem. Keep, change, flip. So 3x minus 1. Good thing is it's already completely factored. So that's the nice thing about this. Denominator is 2x plus 5. And then multiplying it with the flipped version of the denominator fraction. So 4x on the top and then 6x minus 1 on the bottom. So it is just a keep, change, flip because it is just division. You keep the numerator fraction exactly as it is, and you flip the denominator fraction over and you multiply them together. So the x minus 1s are going to cancel out here. There's a couple things that are going to reduce and cancel. So x minus 1s are going to cancel. This 4 and this 2 can reduce to 2 over 1 because you can divide both of them by 2. And I think that's about it. Oh, well, the 3 and the 6 as well, I guess. So 3 and 6 can reduce to, if you divide both of them by 3, by 1 over 3. Now, the numbers probably is not as important because you can multiply them together and simplify at the end. But I went ahead and simplified it now. So that's going to make it look kind of messy, but it'll work. So on top, we'll have 2 x, because that x is still there. X plus 1. And then on the bottom, we'll have the 3 and x plus 5. Did I do something wrong? I think I wrote something down wrong. I don't see. Is that my answer choice? It's not. Hold on. I got to figure out what I did wrong. So let me work this out one more time because maybe you guys saw it, but I didn't see it. So 3x minus 1, x plus 1 over 2x plus 5 times 4x over 6x minus 1. So cancel those. Let's just multiply across. So this will be 12x x plus 1 over, oh yeah, I must have simplified or canceled something out wrong that I wasn't paying much attention to. On the bottom, 2 times 6 is 12, and then x plus 5. So yeah, that clears that up. So that'll be x plus 1 over x plus 5 as a result. So I don't know what I did wrong the first time, but I'm sure you guys will, give me a hard time about it. But anyway, that's going to cover it for rational expressions. I'll see you in the future. Good luck on your exam. Can't wait for you guys all to just pass with 100s and stuff. So have a good day. Bye.